Okay, so we're going to continue now looking at some more examples of substitution. We begin by considering this system of equations. Now again, the first step in substitution is to pick an equation and solve it. If, as is the case in this problem, that's already been done for you, then let's take advantage of that. There's no need to go do extra work. So here I would say I already have y equals 2x. Step 2 is to go to the equation now that you haven't used yet and replace that variable, in this case the y, with what it's equal to, 2x. So we go into the equation 5x minus y equals 9, replace the y with a 2x. That gives us an equation now that has only a single variable. And so we proceed to solve that equation. In this case it's fairly straightforward. 5 minus 2x is equal to 3x. We get 3x equals 9. Divide both sides by 3 and we find out x is equal to 3. Once we know what one of the variables is, we can go back to any of our starting equations and plug that in. In the case of the substitution method, it's generally easiest to go to the equation you've already solved. So we go into y equals 2x, replace x with 3, and we find out y is equal to 6. Now, generally speaking, a lot of times we'll write our solution down as a point. This is particularly true if you're doing the online homework. They like the answers as points. So moving on, let's consider a second example here. We have the equation x plus 3y equals 4, 5x minus 2y equals negative 8. So what we want to do, step 1, is to pick an equation and solve it. Now, as I look at my equations here, I want to solve for one of the variables. I went ahead and picked that first equation because if we look at that closely, we see that the x doesn't have anything in front of it. It doesn't have a coefficient in front of it. So that means it's actually going to be easier to solve for. If you solve for any of the other variables, if we solve for y in that equation, we'll have to divide by 3. If we solve for x in the second equation, we'd have to divide by 5. If we solve for y in the second equation, we'd have to divide by negative 2. And doing that has the potential to introduce fractions. Sometimes there's no avoiding it, but when possible, we like to pick something easy to solve for. So here I want to solve that top equation for x. And I can do that by just moving that 3y over to the other side. And so I get x equals 4 minus 3y. Okay, and then again in substitution, the next step is to go to the equation that you have not touched yet. In our case, this would be 5x minus 2y equals negative 8. Replace the x variable with that expression, 4 minus 3y. Okay, in doing so, gives us an equation now that has only a single variable. It has only a single variable in it. So we can now proceed to start solving. So what I've done here is multiply through by the 5. You get 20 minus 15y minus 2y equals negative 8. And now we just proceed to solve that equation. You may want to pause the video for a moment and go ahead and do that. Here we combine our like terms. We have a negative 15y and a negative 2y. So we put those together, we get 20 minus 17y equals negative 8. And now at this point we want to get y by itself. So we can take that 20 and subtract that from both sides. And we get negative 17y. And then negative 8 minus 20 would be negative 28. And so finally now, divide both sides by negative 17. We get y equals 28/17. Again, once you know what the value is for one of your variables, you can plug it back into any of the equations there involving x and y and then solve for x. If we're going to pick, though, let's choose the equation that we've already solved. X equals 4 minus 3y. So we plug that in. Now it's going to be a little messy. We're going to have 4 minus 3 times 28 over 17. So we multiply 28 over 17 by 3. Alright, so at this point I'm going to have a common denominator to add these fractions. So I'm going to take that 4, which is really 4 over 1, and I can rewrite that as 68 over 17, and then 3 times 28 is 84, so it'll be 84 over 17, so we have 68 over 17 minus 84 over 17, and so we just simplify. We get that x is a negative 16 over 17. Okay, so these are some examples of our substitution method, and we'll continue in our next video.